Hi, I'm Milad and you're watching Science Mentor. In this video, we're going to model an Allen bolt from scratch from 0 to 100 using AutoCAD 2026. Hey everyone, welcome back. To start off, I've prepared a table with all the bolt specifications, things like height, diameter and so on. Everything you need is there. Alright, let's launch AutoCAD 2026 and get started. Since we're working entirely in millimeters, the first thing we do is set the drawing units using the units command and switch them to millimeters. Next, I use the circle command. You can find the icon under the Draw tab to draw a circle with a radius of 1.5 millimeter. This is actually the cross-section of the bolt we're going to create. Then, using the Extrude command, I give that circle a height of 15 millimeter to turn it into a cylinder. Switch to 3D view, and you'll clearly see the cylinder. I changed the visual style to conceptual so we can see the solid more clearly. Now let's create the thread path. For that, I use the helix command. I start by selecting the center point at 0, 0, then set the base radius to 1.5 millimeter, same as the cylinder. After that, I define the top radius and then go into the turns option to set the number of thread turns, which is 15 in this case. Each thread pitch is about 0.5 millimeter, so the helix spacing is set accordingly. As you can see, the helix sits perfectly on the cylinder, no overlaps, no offsets. Now, we need a profile for the thread cut. I rotate the view slightly to find the start point of the helix and use the circle command again to draw the profile. Note, thread profiles can be triangular or trapezoidal, but for simplicity I'm just using a circular profile here. The diameter of this profile is set to 0.5 millimeter, same as the thread pitch. Now we need to make sure this profile is perpendicular to the helix path. I use 3D rotate to align it correctly. Once the alignment is done, I use the region command to convert the profile into a closed region. So now we have a solid circular profile ready to be swept along the helix. I use the sweep command to extrude the profile along the helix, basically turning it into a spring-like solid. Let's rotate around and view the model from different angles. Now, to create the actual thread cut in the bolt, I use the subtract command to subtract the helical volume from the cylinder. Next, I move to the bolt head. Using the elev command, I set the working plane height to 15 millimeter so we can build on top of the cylinder. Then I draw another circle for the bolt head. This one has a diameter of 5.5 millimeter, which matches the real world size. Again, I use extrude to give it volume. Now, for the hex socket, the part where the Allen wrench goes, I set the height to 16 millimeter and draw a polygon using the polygon command. Since it's a hex shape, I set the number of sides to 6. Then I extrude this shape down into the bolt head and use Subtract again to cut out the Allen keyhole. And there you have it, the bolt is almost ready. All that's left is to smooth out the edges a little. I do that using the filletage command. I set the fillet radius to around 0.1mm and apply it to the sharp edges to give the bolt a more realistic finish. And that's it, the Allen bolt is done. You can now check it out in realistic view from all angles. Thanks for watching. Don't forget to follow Science Mentor for more AutoCAD tutorials and modelling tips.